Welcome to a lesson with Dr. Powell. Let's take a look at how we might draw the graph of f of x is equal to x squared minus 1 all over x plus 2. Okay, now let's factor this a little bit. X minus 1, x plus 1 all over x plus 2. Now, step 1, we graph an associated polynomial. So let's do that down here. And we're going to be modifying this graph as we go. So imagine this is the x-axis. Maybe I can redo that. Okay, and then we think of the associated polynomial that doesn't have any division in it. So we're going to have at -2, -1, and a +1 some zeros. Multiplicity 1 for each. Looks like, and behavior will be like an x cubed. So it looks like it's going to go down, then up, and it's going to go straight through. Shoot through, and shoot through. Just like that. Okay, something like that. And we're going to be modifying this. Okay, first, let's modify it by its end behavior. What is the graph eventually going to bend toward? So let's see. We have a division problem, and we find the quotient. So we take x plus 2 divided into x squared minus 1. Now, we could use synthetic division here because the leading term has a 1x to the first power. So we change the sign of the 2 to -2, have a 1, put a 0 for the middle guy, and put a -1. So here we drop the 1, multiply by -2, add, multiply, and then we get something over here, +3, sorry. So notice that the quotient actually is the end behavior, x minus 2. Eventually, this graph will look like the line y equals x minus 2. So let's think about that for a minute, x minus 2. So if this were a y-axis, and suppose that we had maybe -2 right here. Let's see if that looks right. Actually, my graph is a bit off just because of that. Kind of in this particular case, I kind of extended that a little bit. But the idea is that this graph that I've just drawn right here is going to bend toward that line. So maybe for sake of picture, I should just compress this a little bit so it looks a little bit more workable. So maybe we'll have, let's put 1 right here, -1 and -2. And right now we know the graph is going something like that and like that. Yeah, like that. Okay, so that's what the graph is going currently. But we're going to modify things a little bit. Let's go down here to -2 and think a slope of 1. Okay, so eventually the curve will bend toward this line. So dotted right here. Okay, maybe like sorry. Okay, something like that. Okay. So eventually the graph will bend toward that line. So as I'm drawing this, we can think, okay, eventually it'll go down that way along that line. And eventually right here, it's going to kind of match and go along this line. This line is an asymptote because it's a guiding line. Sometimes, since this asymptote is not horizontal or vertical, we often call it a slant asymptote. There are 2 types of asymptotes that you will see on these rational function graphs: end behavior asymptotes and local asymptotes. The end behavior asymptotes are always done by a y equals the quotient. So it's like a function. meaning it can't be a vertical line because a vertical line isn't a function. So you have y equals asymptotes and you have x equals asymptotes. The x equals always comes from the local behavior. The y equals always come from the end behavior, namely from the quotient that we get when we divide. So end behavior are from quotient, and the local behavior are from looking at the denominator and seeing where it blows up, its domain issues. So we have two different types of asymptotes. We have domain asymptotes, ones that concern certain points of the domain, and we have quotient asymptotes, ones that are simply just the quotient. Usually we only have one of these for a fraction of polynomials. So we have one end behavior asymptote, but we could have multiple domain or vertical asymptotes. So here we only have one end behavior asymptote, and it's not a horizontal line like it was when he said y equals 0 in the other example, but in this example, it's y equals x minus 2, which is slant, so it's bent. Now let's take a look at the local behavior. Notice that the things that come from the top are good. These are good. There's only one issue. It's this one that comes from the bottom. And so in step 3, we fix that. We draw a vertical line when we fix it, and then we see if we're under the x-axis right here. See how we're under the x-axis? We need to stay under the x-axis. So it looks like we're going to stay under it, and we're going to be going down this way. And since we're also going to be matching this, I actually think it might look something like this. See how I'm going to be matching the end behavior and be going downward? So I might draw something like that. On this side, I can't go down since I'm on this side already, so I just have to go up. And I go up like this, and I get something like that for my graph. If I want to make it pretty, maybe I can make it smaller here and just think, I kind of have an asymptote here, and we kind of have an asymptote going on right here. And we kind of have something like goes like this, and we have something that roughly goes like that. You can check it on your calculator if you want, but you get something along those lines. Thanks for watching.